Hello and welcome back for the last session for the 10 to 11-3 notes. Today we're going to take what we've learned in this section, especially the area of sectors and the arc length problems, and we are going to solve for unknowns given information. And so now we won't necessarily be solving for arc length, we might be solving for the radius or for the angle measure. And let's get started. Number one, what is the angle measure? So we're looking for the angle measure of an arc pi feet long. So the arc is pi feet long. And so this is telling me together that this is length. So we have arc length. If the diameter of the circle is 8 feet. So a couple of things. I know it's arc length, so I'm going to need the arc length formula. And we're going to use the one we've learned yesterday. So part over whole equals part over whole. I choose arc length because it talks about an arc being feet long, so in units. So pi over 360 equals the arc length over 2 pi r. Now notice it has the r. I was given the diameter, so the diameter is equal to 8. Well, I know the radius is half the diameter, so I would divide it by 2, and 8 divided by 2 is 4. All right, so let's plug in what we know. We are solving for the angle measure. That is the theta. Now I could change that to a variable, or I could just leave it as theta. I'm just going to leave it as theta. So I've got theta over 360. What's the arc length? What is given to us? It is pi. It's 1 pi, or just pi, over 2 pi. And then what is our radius? Well, we said the diameter was 8, so the radius is 4. All right, so this is a little different because I don't have a number in the angle measure. So we are going to reduce this side first. And so one thing I notice is, well, we'll get there in a second. So I'm going to rewrite this. Theta over 360 is equal to pi over 2 times 4 is 8 pi. And so in this case, the pi's, we'll put apostrophe, even though it's not quite right, the pi's are going to cancel out. And so look, there's one on top, one on bottom, so they cancel out. So I have theta, remember that's my unknown, over 360 is equal to something over 8. Well, what goes in the numerator if they cancel out? Well, remember I said it was 1 pi. So there's really a 1 up here. If things cancel out and the numerator is left empty, put a 1 in there. All right. At this point, we're going to cross multiply. Probably the weirdest thing here is recognizing that theta is your variable. It's just a new variable for you guys. I'm going to go this way. And so I have theta, 8 theta, sorry, because 8 times theta is 8 theta, is equal to, and 1 times 360 is 360. Again, theta is sort of a weird variable. And so I'm solving for theta. 8 theta means 8 times theta. So I'm going to divide by 8 on both sides. And I get theta is equal to, and let's figure out what it is. So 360 divided by 8. And I get 45. So that means the angle measure is 45 degrees. 45 degrees. So we still use the same formula as yesterday and the day before of part over whole equals part over whole. We read the problem. We saw it involved arc length and angle measure. So we set it up. So theta over 360 is equal to the arc length over the entire circumference. So part over whole in degrees equals part over whole in terms of the circumference. We plugged in what we knew. Thetas are unknown, so I left it as theta over 360 is equal to pi, because it said the arc was pi, over 2 pi, and the radius was 4. Diameter was 8, the radius is half of it. In this case, we're going to reduce. We multiplied the 2 times 4 and got 8. And then we noticed the pi's would cancel. And so I'm left with 1/8. So theta over 360 equals 1/8. I then cross-multiplied and got 8 theta equals 360 degrees. And then I divided by 8. So the arc measure is 45 degrees. The central angle measure is 45 degrees. All right, let's move to the next one. Number 2. What is the angle measure of an arc bounding a sector with an area of 10 pi square kilometers if the diameter is 20 kilometers? So again, we're solving for angle measure. We have an arc with an area. So a sector with an area of 10 pi square kilometers, and the diameter is 20 kilometers. So we're going to be dealing with area. So part over whole equals part over whole. The angle measure, that's the degrees, so I want to use this fraction. We're also dealing with sector area. So I'm going to do the area of the sector over the whole area of a circle. Area of a circle is pi r squared. All right, so let's plug in what we know. Theta is my unknown, so it's my variable. 360 is always how many degrees are in a circle. The area of a sector, let's read our problem again. A sector with an area of 10 pi square kilometers. Now, what do I need to worry about with the square kilometers is really nothing. Just know that they're kilometers. And then the diameter is 20. Remember, to get the radius, we're going to take the 20 and divide by 2. So that's equal to 10. And it's pi r squared, so pi times 10 squared. When we go to reduce this one, we got to be careful. The first thing we're going to do is we are going to square the radius. All right, so the left side stays the same. Theta over 360 is equal to 10 pi. Well, what is 10 times 10? 10 times 10 is 100. So 100 pi. A number goes in front of the pi symbol. All right, we still can reduce here. And then we're going to reduce the numbers and the pi's. The pi's cancel out. 10 goes into 100 how many times? 10 and 1. Now, if you're not sure, I can do 10 divided by 100, and then I'll math frac it. So math and then frac gives me 1/10. So I have pi over 360. I'm not pi, sorry, theta over 360 is equal to 1/10. All right, so now we're going to cross multiply. Theta is what we're solving for, so that's our variable. 10 times theta is 10 theta. And 1 times 360 is 360. Again, we're solving for theta, so I'm going to divide by the coefficient, which is 10. All right, we want to get theta by itself, so I'm going to divide by 10 on both sides. And I get that theta is equal to 36 degrees. And that is my answer. I know theta means arc measure, which is also the angle measure. And so it is in degrees. All right, so go ahead and turn the page. Another type of problem that we'll see. So what is the radius of a circle that has an arc with length 4 pi units? So we're doing arc length that has a measure of 60 degrees. And so this is degrees. And so I want to set up a part over whole equals part over whole that has degrees and arc length in it. All right, this time we're solving for the radius. So I'm going to do theta over 360, that's the degree sign, is equal to the arc length. And what is the length of the entire circle? What do we call that? We call that the circumference. Circumference. And so I got to think about it. What is the formula for circumference? Circumference. Let's see. Arc length over, because this is the total length around the circle's circumference, and that is 2 pi r. You probably could have gone straight to this one, but I wanted you to see it was circumference was the total. And so this is part over whole. I'm going to plug in my numbers. It tells me what theta is. 60. So 60 over 360 is equal to, well, the arc length, I do know that also, 4 pi over 2 pi. And then r is actually our variable. We're trying to find the radius. All right, so how are we going to do this? Well, we're going to reduce first because I'd like to deal with smaller numbers. So we're going to reduce and we're going to reduce. We're going to reduce both sides. So if you got fractions and you can reduce them, you want to reduce them. Make life easier. So I'm going to do 60 divided by 360 and hit the math and then frac. And I get 1/6. So 1 over 6 is equal to, well, let's see what's going to cancel out over here. The pi's cancel out. I know when you look at the problem, you see 4 pi and you might freak out, but you actually want the pi so that they cancel out. And 4 over 2 reduces. 2 goes into 4 how many times? 2. So let's look and see what we've got on the top. On the top, I've got a 2, and on the bottom, I've got an R. So there was a lot going on there, so I just circled it to see what I had. So I get 2 over R. So 1 over 6 is equal to 2 over R. I'm going to rewrite that over here. And how do I solve this? I got a fraction equal to a fraction. I'm going to cross multiply. So 1r is equal to 1r. Do I really need to put the 1 in front? No. And then 6 times 2 is 12. Now this is radius, so it's not degrees. Let's see, what are the units? Oh, it just says units. So I'm going to write units. So the radius is 12 units. So I read the problem and I said, hey, it's talking about arc length and it's talking about degrees. So I want to set up an equation that has the degrees and the arc length. And I'm going to do part over whole. So degrees part over whole is equal to the circle length part over whole. And the whole length around the circle is the circumference, which is 2 pi r. I plugged in the numbers. I reduced the fractions. And then I cross multiplied. It was nice when we reduced, we got something a lot simpler. All right, next problem. What is the radius of a circle that has a sector with an area of 72 pi inches squared and an arc measure of 180 degrees? So again, we're going to find the radius. We've got area of a sector and an arc measure, so that's degrees, 180. So this is area and degrees. So we're going to do part over whole equals part over whole. Part over whole equals part over whole. I'm going to keep the degrees on the left side because we've done that. Remember, the part in degrees is always theta, and the whole for the degrees in a circle is 360. Now the part for the area would be the area of the sector, and the whole area, we'll just go ahead and put total area. All right, so we've got theta over 360 is equal to the area of the sector. And then there is a formula for the area of a circle, and that is pi r squared. You need to know the area formula for a circle and the circumference area of a circle. Circumference formula of a circle. All right, let's plug in our numbers. Do I know what the angle measure is? Well, angle measure and arc measure are the same value. We learned that. And so I have 180 over 360 is equal to, did they give me the area of the sector? Sector with an area of 72 pi inches squared. So I've got 72 pi. And the inches squared, I don't need now. I just need to know that inches is what my units are. Then over pi, and we're solving for the radius, so r squared. All right, we can reduce this fraction. We can also reduce something over here. All right, I'm going to do 180 divided by 360. Maybe you recognize this already. Hopefully you do, but we're going to get 1/2 because 180 is half of 360. 180 is a semicircle. I'm just going to come up here. So 1/2 is equal to, if I look down here, I do have pi's that are going to cancel. Now the r squared didn't have a number, so I have 72 on the top and r squared on the bottom. Well, I have a proportion, a fraction equal to a fraction, so I'm going to cross multiply. 1 times r squared is 1r squared. I'm just going to write r squared. And then 2 times 72. 2 times 72, let me just verify, it is 144 degrees. Now this has one more step because I don't want the radius squared, I want the radius. So how do I undo that squared? Yep, we're going to square root both sides. And the radius can only be positive, so we're only going to worry about the positive square root of 144, and that is 12. Now what are my units? Well, remember, the area was inches squared, so that means we're dealing with inches. Radius is a length, like it's not going to be squared. It's not area. It's just to the first power. So I have 12 inches for my radius. So again, we've read the problem, and we saw what we had, the radius, sector area, and arc measure. So I said, hey, I've got degrees and area. So I did part over whole equals part over whole with degrees and area. Plugged in my numbers, reduced the fractions, cross multiplied, had an r squared, so I have to square root it to get my answer. All right, let's do this last problem. We want to find AH, and this looks a little different. So AH, this is the diameter. It is asking us to find the diameter. We haven't seen it in a while. If it's segment without the line on it, it's asking for the length of the segment. What is the measurement of the segment? So let's see, we've got length of an arc. So this is arc length. It wants to find diameter. I also have degrees. All right, it wants AH. If I can find the radius, can I find the diameter? Good, so we're going to solve for the radius. All right, I've got degrees and arc length. So I'm going to do part over whole with degrees, theta over 360. That's part over whole for degrees. And then I'm going to do part over whole for arc length. So it's going to be arc length on top because that's the part. And then how do I know how far around the entire circle is? Well, that's circumference. Circumference and arc length are paired together, and circumference is 2 pi r. Now I'm going to plug in what I know. theta, and I'll just use this one. Oh, wait, I got to pay attention. The length of NM. NM. Where's NM? We're going to make typo, huh? Let's do this. Hopefully it'll work out. We're going to make this NH. All right, so I know that this arc length is 91 pi. What is the angle measure that goes with it? So I've got to figure that out. Well, let's see. Cover up something. So I have a line here. How am I going to find the other angle of the line? Well, I'm going to do 180 minus 24. 180 minus 24, let me verify that. And that's 156 degrees. So I've got 156 degrees. All right, so now I know I need to plug in 156 because that's what goes with the 91. So 156 over 360 is equal to, well, the arc length was 91 pi over 2 pi r, because that's what we're solving for, is the r. All right. Now we're going to see how well these numbers reduce. We're going to reduce, and we are going to reduce. Over here, the pi's, does 2 go into 91? Nope. So I have 91 over 2r. I'll pull out my calculator, and I have 156 divided by 360. And then I'm going to hit math and frac, and I get 13 over 30. 13 over 30. And then I'm going to cross multiply. 13 times 2 is 26. So I get 26r is equal to, and then 91 times 30, I'm doing that on my calculator, 2,730. Then I'm solving for r, so I'm going to divide both sides by 26, and I'm hoping 26 goes in evenly, and it does, and r is equal to 105. Now that seems like a degree measure, but remember we're solving for the radius, so let's see, what are the units? Well, we were in millimeters, so this is 105 millimeters. So our radius, oops, that's not my answer, is it? I just remembered. We've got to be careful. AH is the diameter, and so the diameter is equal to 2r. So 2 times 105. And so the diameter is 210 millimeters. Now things aren't drawn to scale, but that's okay. We just needed a visual for our circle. All right, so we read the problem. We have arc length, and then we had degrees. So we did part over whole for degrees and part over whole for arc length. You've got to know that 2 pi r and arc length go together. I plugged in what I knew, and then I reduced, and then I cross multiplied, and then I solved by 26 on both sides. And after I wrote the box, I remembered that we were solving for diameter. So diameter is equal to twice the radius. So I multiplied 105 by 2 to get 210. Make sure that you pay attention to where this is and where the angle that it matches up. Just don't assume it would. All right. So if you need help, I'll be around. On Thursday, I will be at school. So feel free to email me or Zoom, and you're going to do great. All right. I love each one of you. Bye.